Today I'm going to talk to you about scanography. I've been doing some images lately and popping them up on Twitter and Facebook, and people have been asking me about how do you do this scanography lark. And it's a technique I use quite often. It's one of those things that you might do sometimes in the winter months when you can't get out and do any photography. At the moment, it's red hot outside, so I'm doing some stuff indoors. Anyway, let's talk about what you need to do it. Obviously, first thing you need is a scanner. And my recommendations are to have a flatbed scanner, the deep type scanner, and I'll show you mine in a minute. The thinner, what we call the light scanners, which are quite narrow, you don't get enough depth of field on those. So you can't get those nice deep scans that you might have seen on some of my images. But I'll show you the scanner I've got. It's an Epson Perfection V550. And I use that because I can also scan negatives and slides as well. So it's really good. I can scan at quite a high resolution on it. So let's show you what I've got. Now this is the Epson, as I mentioned, the Epson Perfection V550 photo scanner. And you see I've already got something on the top of the scanner bed here. And obviously the back's up. Now if I wanted to lay something on that scanner that's sort of quite deep, then I can't obviously shut the lid down because the lid's going to squash everything I have on there. So what you need to do is you need to find yourself a couple of boxes, and I'm going to show you the ones that I'm using. So I have this box, these boxes here. They're just normal storage boxes that you can use. But what you have to do is line them inside, either with black or with white. I'll show you this one. This one is just the top part, and I've just sprayed it inside with some matte paint, black paint, and then it's lined inside with some black card as well. You need to keep it as clean as you possibly can and not let any light in when you pop stuff on the scanner. And we just pop that on top of the flowers. You saw them on the scanner earlier, and we just pop that on top, and then we do the scan. So we're going to go in now, and I'm going to show you the scans, and we'll be on the computer from now on. So I'll speak to you later. So we're on the desktop now, and obviously your software, if you're not using an Epson scanner, then your software will look a little bit different to this, but we're just going to talk you through this, but the principles will be the same. So you can probably, it'll be relatable. So what we're going to talk about in this session, there's going to be a little bit about PPI, pixels per inch, and DPI, dots per inch, and there's often a little bit of confusion about those. So we're going to sort of talk about them in a little bit of detail so that you understand them hopefully a little bit clearer when we come to the end of this. You'll see in the left-hand box here, I always set it into professional mode with the Epson because I don't want it to do anything automatically. I want to be in control of the scan. And if we stay in professional mode, we've got all of the features and functions that we need in the software. And when I do a scan, I don't really want the software to take over because I'll be pulling it into Photoshop and I'll be doing the changes in there. So I don't want to set anything like unsharp or sharpening, and so I'm not setting any of these at all. I don't want to set any adjustments. I don't want anything on auto. I just want to be able to scan it in the way I want to. And in this case, for the type of document, we're talking about reflective, which is basically anything that you're going to lay flat on the scanner, like a piece of paper or anything like that. And because I can do film and negative scans on here, there's an option for doing film scans. The document table is basically the source, this bit here, which is the document table. And the type of exposure I'm doing is a photo rather than a document. Now then, we come to this bit here, and this is something that people perhaps might get a little bit confused about. So I'm going to talk a little bit about bits and things like that. We'll talk first about images that you might take with your camera. When you take an image, a JPEG image in camera, it's generally what we call an 8-bit image. And if you take an image, a raw image, it's a 16-bit image. And now, what do we mean by 8-bit and 16-bit? Basically, the bit size, the bit depth, is the amount of colour data that's in the image. So an 8-bit colour image will have less colour data in there than a 16-bit image will have, like your raw files. And if we were to say, look at it from colour gradations, in other words, if I've got an 8-bit image and I've got a colour, say a shade like of red, then an 8-bit image will have up to 256 colour gradations, whereas a 16-bit image can have up to 65,000 colour gradations in one colour. So you can see the difference you might get in an 8-bit JPEG image and a 16-bit raw image. And I don't think people explain to you when they say, oh, you get more information or more data in a raw image. It's basically giving you more colour information, so you're less likely to get banding and things like that, and the colour gradations will be smoother. And so it's always my recommendation to use raw images in your photography. Now, when it comes to scanning an image on a scanner, you've got two choices, and this is where it can come a bit confused. You think 24-bit colour or 48-bit colour. Now, which one do I go for? Well, if you think about the images are created from the red, green and blue channels. What a scanner does is it scans each channel separately when it's doing the scan. And with a 24-bit colour scan, it's going to scan each channel at 8 bits. So 3 times 8 bits is 24 bits. If we look at the 48-bit option, it's going to scan each channel, the red, green and the blue, at 16 bits per channel. So 3 times 16 is 48. So we're going to get a 48-bit colour scan, and that's going to give us a 16-bit image. So the equivalent effectively to like a raw file if we scan at 48. Now that's going to make the image size significantly larger. So a 48-bit colour image scanned on here at full size, which is the full document bed size, will be about 100 megabytes. Now, I've got a choice here. I can scan it at a variety of different resolutions. Now, it's telling me here that it's DPI, dots per inch. Now, for anybody that does printing, it seems to be quite a hard one to get the head around. If we think of PPI as being an input resolution. So when you think of pixels per inch, it's usually what you're viewing something at. So if you've got a screen, it will display at so many pixels per inch. Or if you've got a camera viewfinder, it will display at so many pixels per inch. When it comes to print, DPI is an output resolution. In other words, it's how many dots per inch are going to be printed on the paper when you print it. And generally people talk about things like, or print out at 300 DPI. And yes, that might be my suggestion, because if you start to print at higher DPI, say 600 dots per inch, you're not really getting a better print. You're just using more ink on the paper. So the given seems to be around about 300 DPI. If I scan this image at 300 DPI, it's going to be an 11 by 8 image. Now, I want this image to be a much bigger image. I want it to be almost double this, so 23 inches about. So there are two ways I can do this. I can choose to scan it at 300 DPI and increase this scale by 200%, which will have the effect of... Oops. Which will have the effect of increasing the size to 23 inch, or I can do it by setting the DPI to 600, which is basically doubling the output resolution. And we'll have a look at that when we go into Photoshop, and you'll see the effect that has. But it's effectively the same as doubling up or scaling it up by 200%. Now you won't see this change because it can't. That's the size of the bed. And once we've done that, the first thing we're going to do now is we're going to go to preview, and we're going to look at the preview. We're going to let it scan the image, and we're going to get a preview of the image. There we go. I've got 3 flowers on there. Now, you'll find with a scanner that you'll have little bits of dust and everything. You'll get bits you'll have to pick up, and you'll have to tidy that up when you get it into Photoshop. But you can see here, I'm quite happy with this. If we wanted to, we could create a little marquee, and we could size that up and down. But if you look to the left on the thing here, you can see that we're actually changing the size of the image, because it's actually going to change. If we look at the numbers on the left, that's changing all the time. So I'm going to not bother with that. I'm going to delete the marquee, and I'm just going to scan it at that full size there, because I can do any resizing I want to in Photoshop. So at this stage, we're going to click scan, and it will ask me if I want to where I want to locate it. And in this case, I'm going to save it as a TIFF file, and I'm going to click OK, and it goes off and it'll do its scan, and it won't take long. Now we can see it's done the scan, and we will open it up in a minute, but I just wanted to say something about these adjustments here. When you've got it on the bed, you can make some adjustments. In this case, I've got like a levels adjustment. I can actually adjust the scan on here, and what I would tend to do, if anything, is I tend to flatten it a little bit and make it quite less contrasty. Occasionally might bring the blacks down, but I'm going to do most of my adjustments on the on Photoshop. So we're going to close that, and we're going to go into Photoshop now, and I'm going to open the files. I've got some files I did earlier, so I'm going to show you those. So we're in Photoshop now, and I've actually got 3 files open because I wanted to show you the difference in sizes and things like that. So we've got 3 images here, and we've done 3 of these images. They're all TIFFs, and you can see if you look on the top of your of the window for each file, you'll see I've scanned this one as an 8-bit file. I think this one, if we go into image and image size, you'll see it's an 8-bit file, and it's been scanned at 300 resolution. That's that one, and you see that's a 25 megabyte file. The second one has been scanned again. It's been scanned at 300, but it's been scanned this time as a 16-bit file. So we've got a 51 megabyte file there. So that's been scanned at 16 bits. So that's a 48-bit on the scanner. And then the third one is the full-size image, which is a 16-bit scanned at, go in here, we'll see it's been scanned at 600 DPI resolution. And that is now a 204 megabit file. So you can see you can actually scan quite large files. So let's have a look at the 300 megabit file, and I'm just going to show you something and why it's important that you scan them at the higher resolution at 600 DPI. So if we go into the image size information here, we can see here this is a 25 megabyte file. It's 2,550 pixels by 3,509 pixels, and the original size of that is 11 inch by 8.5 inch. Now, so let's pop this image up to 23 inches, leave it at resolution DPI, and it's going to resample. And whilst I've still got the 300 DPI resolution, it's going to resample that image. And what do I mean by resampling is basically that Photoshop will interpolate the data to make that image bigger. And by interpolating the data, it's basically guessing what data needs to go in there, what colour data. So it's got the effect sometimes of softening an image. So whilst it does quite a good job, does Photoshop, it's not always the best way to upsize an image. The best thing is to scan it as a higher resolution as you possibly can. Just to show the effect, let's just cancel that, and let's just show the effect of not resampling. if I go to image size again. So now I'm not going to resample, and this time I'm going to try and pop it up to 23 inches, and I pop it up to 23 inches, and you see it's now effectively reduced the resolution. So I've gone down to 152 dots per inch, which from a point of view of printing is not going to be very suitable. So ideally we're looking at scanning at as high a resolution as we can in respect of the size of the image that we want. I just wanted to show you those. Now this image, which is the 16-bit, so this is the 8.5 by 11 inch image, and it's at a resolution of 600. Now this has been scanned at 600, so it's high resolution, and you can see there that I've got a lot of data in there. Now then, I'm going to untick the resample, and I'm just going to say, right, let's do that at 300 DPI. And now I've got a 23 inch image by 17 inch, but I've not lost any data. I've not lost any information data in that at all. So if I wanted to print that at 300 DPI, I can print up to about 23 inches with that image. So you can see the image size has also gone up from 5,100 pixels to 7,019 pixels. So I've got a lot of flexibility by scanning that at the higher resolution. So you can see there the difference between scanning at a lower resolution and sizing it up, or scanning at a higher resolution and sizing it down. Now, when it comes to DPI, people seem to have a lot of confusion about this in respect to putting their images on the web. Let's go back to this image and have a little look at the size-wise. Now, I've got this image at 600 DPI. It's quite a large image, and I want this to actually be put on the web, and so I don't want it to be big enough for people to be able to resize it up and reuse it. Now if I keep that resample ticked and I pop this down to 72 DPI, what will happen is it will resample the image for me at a lower resolution. So you see how the dimension's gone down to 612 by 842. So if I now click OK on that, I've got a much smaller image, and if I were to pinch that off the internet, as it were, so I've got this image, I think, oh, that's a nice one, I'm going to size it up, and I'm going to now size it up to 300 DPI to print it. It's still an 11 by 5 image, but there's less pixels in it. So if I now resample that back up at 300 DPI, what's happened is, you see how pixelated it's become? So anybody trying to print that at 300 DPI is going to find that it's not going to look good. So I'm just going to cancel that, and we'll just take that back to what it was previously. Let's scroll out. It's back to the size that it was. So once you've got your scans then, that's a little bit about DPI and PPI. I hope that's not confused you too much. It can be a little bit confusing, but always remember PPI is a if you like, a viewing resolution, whereas DPI is really an output resolution. So I hope that's made that a little bit clearer. And we're going to put that one away, and we're just going to look at this one, because there are some things you need to work on once you get the image into Photoshop. And if we just have a look at a few, you can obviously see there's things like scratch marks and dust. So you might want to just sort of create a copy of it, and then pick up the clone tool and start going round and knocking out some of the marks that you might get on it. I shouldn't worry if you're going to use it as a multiple layer image. You might not need to do this too much, because some of your textures will sort of overlay those. And you can see I've got a little bit of dark around the outside here. So what I might do is go and try a little levels layer and see what I get. Just seeing how the adjustment can go. You can see it's bringing that black in there. I can darken it a little bit. So you see that's a little bit better. If we look at the before and after, that's brought some of the black in there. So again, just make the adjustments as you see fit based on the image. You might find that you've picked up little bits around the image when you zoom in, little bits of little hairs and things. There's a little bit there. You just need to zoom in and check through and see what you get. So you can see there's lots of little bits all over. Well, that's probably on the screen, that. So go around and check it and see that there's everything. I've got a bit of dust on my screen, so I'm going to have to be trying to clone out a dust mark that's on the screen. So you get the idea, and you can go in and then obviously save that as a however you want to save it. And then you can do what you want with it. And if we look at another one I did earlier, that's this one. If we just switch off all those layers, you can see this is one I've pulled in and done some masking on this. I'm only going to go through and show you the various layers on there. That's a texture layer on there. Then I've added some other scans in that I've done. We're building this up as we go. Curves, a hue, saturation, levels, colour lookups and things like that, and then bringing in another image and keep applying adjustments until we get to the final image, and that's what we've ended up with this one. And you can have a lot of fun with scanning. You can put anything you want on the flatbed. One thing I would say is if you're going to put anything hard or that might scratch it, you can use an acetate or a piece of clip frame glass on top, just so that you don't mark it, and have a duster and a little bit of cleaning fluid available just to keep it clean if you get any sticky bits on it and things like that. But you can have a lot of fun with scanography and build your images up and do whatever you like with them. Put anything you like on there. And so I hope that's been helpful. I hope it's given you a little bit of understanding about PPI and DPI. Remember that PPI is an input resolution. In other words, it's like a viewing resolution is PPI. In other words, you might see a screen on so many pixels per inch, and that DPI is an output resolution, and so it's based on basically most of the time it's printing or viewing on another device. So I hope that's been useful and you've enjoyed that, and it give you a little bit of enthusiasm to do some work on your scanner. So hopefully see you again soon. Bye bye.